Okay, today's section is section 2.5. It's called implicit differentiation. Okay, and let's first talk about what that word implicit means. So right now we've been working with functions that are stated explicitly. So an explicit equation is just an equation like this. You have it in the form y equals. An implicit function is when you don't have it in the form y equals. So this would be an implicit. And this would also be an implicit. Now the first equation here, you could write it explicitly. You can solve this equation for y, but notice the second equation here, you could not solve it for y. So we still want to be able to take the derivative or differentiate it, okay, in this form. That's what the goal of today's lesson is. How do we take the derivative equations written in implicit form? Okay, so let's start with the real simple equation. So let's start with y equals x. And I'm going to start using the dy dx notation. So if I ask you to take the derivative with respect to x, this is an operation you're performing. The derivative of y with respect to x is dy dx, which is the same as y prime, but this is just notation. And the derivative of x with respect to x we know is 1. Really what's happening is the derivative of x with respect to x is really dx dx, but instead of writing that, we just write that as 1. It's the same thing. Okay? Now, we are eventually going to start taking derivatives with respect to a different variable. So let's say I give you the same equation, y equals x, but this time I asked you to take the derivative of y with respect to t. So this would be dy dt instead of dy dx. And now when you take the derivative of x with respect to t, it's no longer 1 because it's dx dt. So when we get into some word problems later, this is going to represent our change in x over change in time. Okay, so just get, this is the notation I'm going to be using for this section going forward. Okay, so let's take a look at a couple examples. So this is, the way it is written, is an implicit function. Okay, let's go ahead and write this explicitly first. So that means I can solve this equation for y, subtract the y, move the 4x over. So this is really the same as y equals 2x. I want to take this derivative. I know that you know really quick in your head it's y prime is equal to 2, but I'm going to start using this notation. So performing, differentiating this equation, that's what this is doing. You're going to get dy dx, which is y prime. This becomes just 2. We know the derivative of 2x is just 2. It's really 2 times dx dx, but again, we don't write that dx dx. So this we already know how to do. Now let's say that I want to do it from this form. So I'm going to leave it exactly like this. I'm going to take the derivative with respect to x. So the derivative of 3y is not just 3. It's actually 3 dy dx. Right? We learned just up here what's the derivative of y? It's dy dx. So same thing, it's 3 dy dx minus the derivative of 4x with respect to x will just be 4. Again, it's 4 dx dx. That's why it just becomes 4. The derivative of y again with respect to x is dy dx. Notice you have dy dx's on both sides, but I'm looking for the slope, so you can go ahead and subtract the dy dx here. So you have 2 dy dx. Move the 4 over. When you solve for dy dx, notice that your slope is 2. Exactly the same thing that we got here. Obviously, this is the way I would want to do this problem, but the idea is either way you get to the same answer. Okay, let's try one more problem that you can write both ways. So let's say this is my equation here, xy equals 1. This is implicit. Let me give you another equation, but let's take this and write it explicitly. So this is the same as y equals 1 over x. So I'm going to go ahead and do this one. I'm going to rewrite this as x to the negative 1. If I take the derivative with respect to x, I have dy dx. I'm just going to use my power rule, negative 1 x to the negative 2, which is negative 1 over x squared. So this is my derivative. If I do the same thing to the implicit equation, let's see how it's different. Notice here you have two variables. So you have to use the product rule here. So the derivative of the first is going to be 1. The derivative of x is dx dx, which is 1, times the second is y, plus the derivative of the second will now be dy dx times the first. The derivative of 1 will be 0. And now we want to go ahead and solve for dy dx. So subtract the y, move this over, divide by the x, and this is what I get for my answer. Notice though, it doesn't look like the same as this. So when you do a problem implicitly, you will have x's and y's in your answer, which is fine, but let me show you that it is the same thing. So y is really 1 over x. So if you substitute that y in for 1 over x, this simplifies to negative 1 over x squared, which is exactly same as what we got here. So for problems like this, it is probably quicker to go ahead and write it explicitly, but there are certain problems you're not going to be able to go ahead and do that way. Okay? Let's do one more problem implicitly, just implicitly, and then we'll look at an equation that you can't do both ways. Same thing. Derivative with respect to x. Okay. The derivative of y squared is 2y. You have to use the chain rule here. There is going to be a dy dx equals the derivative of x with respect to x is just 1. Now the reason why you have this dy dx here is, what if I wrote, instead of y squared, I wrote y squared as this? The derivative would be, if this is the original, the derivative would be bring down the 2, reduce the power by 1, and then you need a chain rule. That's why you have that dy dx there. So you have to keep in mind that y is the same as f of x. It is a function of x. So if I want to solve for dy dx, this is what I would get from my derivative, and you can leave your answer like that. Okay, one last example. Let's get this one. Here's my equation. And this is an equation you could not write explicitly, so you would have to do it implicitly. So here's my equation. Let's take the derivative with respect to x. Again, bring down the 4, reduce the power by 1. This is a 2-layer function. Your inside just happens to be y. So chain rule gives me 3 dy dx. The derivative of 3y is 3. Remember, the derivative of y is not 1. It is dy dx because we are taking the derivative with respect to x. Minus, this is just 12x squared. Again, there is a chain rule going on, but what happens is it's dx dx, which we do not need to write. If you want to write it, it's fine. The derivative of 5x with respect to x is 5. The derivative of 1 is 0. Okay, I'm going to simplify this. I'm going to go ahead and move the 12x squared over. Both of these have the dy dx, so I can go ahead and factor out the dy dx and move this over. So this is my derivative.